Hey, what's up? It's Jake, and I'm finally going to get around to doing a part 2 of the SSL configuration for EC2 using Amazon Linux 2. I have a part 1 up, so feel free to go through that, but I'm going to do a quick review in case you're just checking this out. This seems to be the most visited and viewed video on my site, so I figured I'd add to it in case anybody had any questions about making this work. So the first thing you're going to want to do is launch an instance. So if you haven't already, go to the EC2 documentation, go to Getting Started Tutorial, and go ahead and launch an instance. When you launch your instance, as you can see here, I went ahead and logged in. Make sure that you create a security group that has, I just made a custom one, that has access at least from your IP for ports 22 to SSH, 80 for HTTP, and 443 for HTTPS. I'm just going to do a quick yum update. Now I'm going to install everything I need for a LAMP stack. Then I want to install a Apache web server. Then I will go ahead and start this web server. Configure for it to start on boot. And then verify that it is indeed running, enabled. For this project, I'm going to go ahead and enable HTTP from anywhere IPv4, and same for HTTPS, anywhere IPv4. Put in the public IPv4 DNS address into a browser and confirm that you are indeed hitting the test web page for Apache. Now we'll go ahead and set some file permissions. And then I'm going to log out and back in, verify group membership. All right, you can see here are my groups. Now we're going to change some group ownership and add write permissions. And then do it recursively. Now to test, I'm going to go ahead and create a PHP file and document root, and then go back to my public address and put a path here for php.info. And there we go. Now I'm going to go ahead and secure my MariaDB server and run the secure installation. I'm not doing anything with passwords really, but if you have questions, you can go through the documentation on installing LAMP on Amazon Linux 2. And I'm going to finish by enabling MariaDB for restarts. Now I'm going to go ahead and install my PHP admin. So let's get some stuff installed here. Then we're going to restart Apache, restart my PHP, navigate to my document root, var.html, and I'm going to get to my PHP through wget, create a folder, and then I'm going to delete the tarball that I used just to kind of clean up a little bit. And then just to make sure, start my DB in case it got stopped. Now I can go again here, and instead of PHP info, my PHP admin, and we should have the admin page. There you go. Okay, so now let's get into SSL. So last time we did the prerequisites, configure the security group to allow ports 2280.443. We are using Amazon Linux 2, installed the Apache web server with the LAMP stack, and we need to identify and authenticate websites using TLS PKI, which relies on DNS. So to use your EC2 instance to host a public website, you have to register a domain name for your web server or transfer an existing one, and I will be doing that and show you with Route 53. So I have already enabled one and registered it because it does take a long time, but if you need to set one up, you can go ahead and create a hosted zone and get yourself a domain. I pay $12 a year for mine. You'll get some basic records that come with it. And then what you'll want to do is you'll want to add a certificate here, and you can do that with Certificate Manager. So in Certificate Manager, you'll want to request a certificate, which I did here, and then this will just be pending forever until here, I'll show you. If you request one, a public certificate, hit next, put in your domain name, jakeispretttycool.com, and then you want to do DNS validation. This is really, really important. This will validate it through Route 53 and automatically add those CNAME records for you, and it's a lot faster. So I'm going to go ahead and cancel this and show you the certificate that I had issued. I went ahead and said create records in Route 53, and it created these CNAMEs for me. And if we go back to Route 53, you'll be able to see this because the CNAMEs are pretty ridiculous looking, so they're easy to point out and easy to notice. So you'll see here, here's my domain, and I have this crazy record name with a crazy route, and this is my certificate. So to get started, what we need to do is enable Apache and then ensure everything's up to date since I installed a bunch of stuff. Once you do that, we're going to install mod SSL. And now we have a confd file in Apache with ssl.conf and then a make dummy cert. So we're going to run a script to generate a self-signed dummy cert for testing. See here. And now I have a localhost cert in the etcpki TLS directory that I just changed to here. And there's our make dummy cert, and there's our certs. The file has both self-signed certificate and the certificate's private key, and Apache requires this to be in PEM format, which has base 64 encoded ASCII characters with the begin end lines. An example of that would be Amazon's here. It looks like this. You've probably seen something like that before. Okay, so now I'm just going to vi etc httpd conf.d and then our new ssl.conf file. And we're looking for a SSL certificate key file. Here it is, certificate key file. And we're just going to comment this out. Oh, I need to do it as sudo. And it's now commented out. And there we go. Let's restart Apache so it picks up the new config. If you don't comment this out, it's going to fail. Now I access my endpoint with HTTPS and I get a warning. This is normal because it is self-signed. So you get this warning that it's not secure. Certificate is not valid. And we can see here that it is a localhost local domain. So the way I like to do this, there are ways to do it locally, but I think the better way to do it is I'm going to go ahead and open up another Amazon tab, and I'm going to go to EC2, and I'm going to create a load balancer. So what you want to do is you want to terminate your SSL somewhere not on the instance just to keep everything safe. So what I'm going to do is I'm going to go ahead and create a target group, instances, target group name, I'm just going to go demo SSL, port is going to be 443, default VPC is what I'm using, HTTP1, a health check on index, which is fine, and yeah, that should be it. Go ahead and hit next. Oh wait, I need a hyphen. Next. All right, so now I have available instance. This is the one that I created, my demo. I'm going to include as pending below. Again, ports for select instance is 443, and go ahead and create the target group with this new instance inside of it. Great. Now I go to a load balancer. I'm going to go ahead and create an application load balancer. See here, create. Load balancer name, demo SSL ALB. Internet facing, I'm going to use IPv4. Network mapping will be to the default VPC. I'll go ahead and just grab all of these just in case. You can do 2 or however many you want. My security group, I'm going to get rid of my default and I'm going to do my SSL demo, which allows port 22, 80, and 443. Once we're done, we're going to delete 22 and 80 and just do 443. For listener, I'll go ahead and leave it a listener on port 80. I don't know why that changed. Oh, because it's a new one. We're going to do 443. A default action is going to forward to my new target group, which has my instance behind it. You can leave all the rest of this as default and go ahead and hit create load balancer. Oh, I need a default action for this as well. Correct? Okay, now, important. This is the part where people get confused. Secure listener settings. If you add HTTPS as a listener on port 443 and default action forward to a target group with an instance behind it, and you have your security group that allows port 443, the next thing you need to do is have it terminate at the load balancer with a certificate. So you can leave this policy as defined, and then I'm going to do it from Amazon Certificate Manager and choose the cert that I had verified. Now you can create your load balancer. Now my load balancer is provisioning, but we can see here that it does allow port 80 and port 443. We will test it on port 80, and if everything looks good, which right now it does, but as soon as this is done provisioning, we'll test the endpoint for the ALB, and then we'll go ahead and test it on port 443 as well. And what we should see is that this non-secure warning goes away because I will in fact be using a legitimate certificate. I did make one mistake. Make sure when you create your target group, you're using HTTPS protocol on 443 and not HTTP. Once you have this assigned to your load balancer and it changes the state from initial to active, just verify your registered targets are indeed healthy. Now, I've got HTTPS in front of here, and you can see that it actually still connects. It still says not secure, and that's because I didn't actually configure my local server with certificates, which is fine. So if I hadn't done all that stuff at the beginning and set up the local certificate, then you wouldn't get this warning. But essentially the idea is still there, and that's that you go to a certificate, you create the certificate, you move the certificate in Route 53, and then the load balancer is going to use that certificate. So ideally what I would do is in my hosted zone, which I can go to here in Route 53, since this is actually created through here, I can create an A record and say create record. Record name is going to be, what do we want to call this? SSL.nimbusdevops.com. And then I'm going to do an alias and point this to a load balancer. And then I'm going to choose a region, which I believe I'm in US East 1. US East 1. Choose a load balancer. Evaluate target health, sure. And then create record. Alright, so now I wait for this to propagate, which really shouldn't take that long. Copy this, and then we'll just wait for this to be able to forward. One thing to add on the health check is to make sure you create an index.html file just so it's got something to point to, or the health check will fail. So there you go. You've got a, it says not secure, but again, this is a server configuration thing. So you have to set this up to get your certificates. AWS Certificate Manager does not provide private certificates. So if that's something you need internally, then maybe you should use a different tool. But, and you can import that kind of stuff. But you can see here that this certificate is actually okay. It's just in Chrome, you're still going to get this warning. So if you haven't looked at it, I definitely recommend going and check out my ECS deployment, where I also use HTTPS to secure an ECS cluster with a load balancer, and in there you can see it does not give a warning. But that's essentially how you would do it. It's just requesting a certificate extra step. So there you go. I hope this helps, and see you in the next one.